Hello and welcome to the session. This is Bhaskar Napte from Pharma Growth Hub. So, as a part of today's discussion, we will try to understand one of the very important common term which is associated with bioavailability as well as bioequivalence study. And this common term is AUC or area under curve. So, as a part of pharmacokinetic evaluation, AUC is a very important parameter along with the Cmax. So there are also different types of AUCs used in the bioequivalence study. So we'll talk about all these different types of AUCs. So let us first understand the definition of AUC. So AUC is defined as the area under the concentration versus time curve. So you can see this AUC over here. The time is plotted across x-axis and the plasma concentration of a drug substance is plotted across the y-axis. And whatever area you can see which is denoted under this curve is called as the AUC. So it is the plasma concentration time profile after a dose. So once the dose is administered, it is going to be absorbed inside the systemic circulation. It will come into the blood or plasma, and that drug concentration is represented under over here. So at the beginning of the study, the concentration of drug is 0, and as the time passes, the concentration of drug increases into the stream and it reaches to the maximum concentration, which is called as the Cmax, and then the concentration of the drug substance start decreasing because of the excretion. So it depends on the absorption, then followed by distribution, metabolism, and at the end the excretion. And because of this excretion, the concentration of drug substance start depleting into the systemic circulation. So what AUC actually reflects? So the AUC reflects the extent of exposure or extent of absorption of the drug into the systemic circulation, because once the drug gets dissolved inside the GI tract, it gets absorbed. So how much quantity of the drug substance is really getting absorbed, or the extent or the total amount of drug getting absorbed is actually measured by the AUC. And this is the calculation formula for measuring the AUC. The F stands for F stands for bioavailability, D stands for the dose, and CL stands for the clearance. So what is the CL? Let us also understand it. So CL is nothing but the body's ability to eliminate drug, and it is expressed as a volume of plasma cleared of drug per unit time, and unit of this clearance can be liter per hour. Now this is the AUC. So what are the different types of AUCs? The first one is AUC 0 to T. So what is AUC 0 to T? So it is the area under the concentration versus time curve from time 0 to the time of last quantifiable concentration, that is called as the lowest analyte concentration that can be quantified with acceptable accuracy and precision, or LLOQ. So what is the concentration that can be measured accurately and precisely? Until that point, the concentration will be measured. So if you can see in this particular curve, again this is the time versus the plasma concentration curve, and in this particular you can see the LLOQ for this particular method is approximately could be I think around maybe 0.25 something like that. So this is the C last, the concentration measured last, and this is the time at which the concentration was measured at the end. So maybe around, I think, approximately 21 hours. Because beyond 21 hours, the concentration available over here is actually not measurable. Look at here now, this particular time slot, right? So this concentration is below the method's LLOQ, and hence it will not be measured. So until the concentration which is above or at LLOQ will only be measured. So I hope you clear about this T time. So that time is defined over here. The time at which the last concentration is measured, that is called as the T last. So AUC means what? The starting point until the last point, and whatever concentration is present from starting point to last point, that is called as AUC 0 to T. And this last time is defined by whom? The last time is defined by this LLOQ, the lowest LOQ, the lowest concentration that can be measured with the defined or acceptable accuracy and precision. So it is just like our LOQ for analytical procedure. So here is the AUC to sorry. So this is the AUC 0 to T plot, area shaded only up to the last quantifiable time, that is T last. Okay. So beyond that, the concentration is not measured because it is below LLOQ. So AUC 0 to T must cover at least 80% of AUC 0 to infinity. So we'll also talk about what is meant by exactly AUC 0 to infinity in upcoming slides. But whatever the uh, area covered by entire curve, which can be denoted as a maybe 0 to infinity, suppose this is 0 to infinity, at least 80% of the curve must be covered by 0 to T. Okay, and this is maybe a 0 to infinity. So 80% curve must be covered by the 0 to T study, and then maybe around 20% could be a 0 to infinity. So there is another important AUC term which is called as AUC 0 to 72 hours. So area under concentration versus time curve from 0 to 72 hours. Last time we talked about the AUC 0 to T, and we understand how to define T over there. But in this case, the T is going to be a very specific, which is 72 hours, as you can see over here. Right? At the 72 hours, we have stopped measuring the concentration. Now, what is the rationale behind selecting the 72 hours? And you can see the details over here. That 72 hours is enough to cover absorption as per EMA's bioequivalence guideline for especially IR formulation. So AUC 0 to 72 hour is used for product which has a long half-life or having the modified or the extended release behavior. The next important AUC term is AUC 0 to tau SS. So this SS stands for steady state. Let us understand this AUC 0 to tau SS. So this is the area under the concentration versus time curve for one dosing interval at steady state. So this is the time versus concentration graph for the steady state study, where the dose is administered at a specific time interval. So you can see this is the first interval, you get a Cmax over here. This is the second interval or the second dose. This is the third dose. This is the fourth. This is the fifth, so and so forth. So what is the purpose of steady state and what is the purpose of AUC 0 to tau SS? So you can read here the definition of steady state also. So it is a in pharmacokinetics, the drug level pattern has stabilized under repeated dosing, and over each dosing interval the amount going in is equal to amount going out. This is ideal situation because uh, as like absorption, there is also going to be excretion at the end, right? So absorption is helping to increase the concentration, and excretion is going to decrease the concentration of a drug into a systemic circulation. So there comes a situation when the rate of absorption is equal to, let us say, a rate of excretion or rate of elimination, I think that's better term. And at that, when the rate of the absorption is equal to rate of elimination, one can think about the concentration of a drug substance is going to be constant across the given time. So even though it is said that this is the situation expected as a part of steady state, this is a very ideal situation, but in reality we can't expect such a kind of ideal situation, and this can be like this one. So what is the tau? Is the dosing interval. So like for example, if the dose is administered every 24 hours, then tau becomes 24 hours. Or if it is twice in a day, then the tau becomes 12 hours. And the steady state is nothing but the after several doses, the concentration time profile repeats each interval. So maybe you can think about the third dose onward, the concentration or Cmax and the concentration of drug substance almost looks to be similar. So to understand AUC 0 to tau SS, we will take one practical case study or the example. So this is the study as you can see over here, and this study is conducted over a dosage of 10. So 10 doses has been given, and the dose amount is going to be the same every time, and the time interval is 24 hours, right? So 24, then 48 and 72, 96. So what is the drug? The X drug is given once daily for 10 doses. The tau becomes 24. So AUC 0 to tau SS is the area over a single 24-hour interval at the steady state. Now, at what concentration the steady state is achieved? See, this is the concentration across the different time, the C tau. So C tau is the concentration at the end of the dosing interval. So at the first dosing interval, the concentration was found to be 50. Then at the second dosing interval, the concentration was found to be 75. At the third dosing interval, the concentration found to be 87. And then at the fourth interval onward, you will see the concentration of the drug substance is almost has achieved a steady state, like 93.75, then 96, then 98, 98, 99, 99, and 99. So what is the dose after which you have found the steady concentration or steady state? I think beyond fourth dose, right? Beyond fourth dose. So means the fourth dose means fourth day, because our dosing interval is 24 hours. So what is the concentration under the curve at fourth day can be called as the area under concentration at 0 to tau SS. Why it is called as tau SS? Because this is the concentration, this is the time when the concentration is found to be achieving the steady state. So you can measure the concentration at the fourth day, and that can be called as the AUC 0 to tau SS. And after that, there is no further increase or much difference in the concentration. So in this example, the 3 consecutive doses are required to achieve the steady state, because in these 3 initial doses, the concentration is varying very significantly from 50 to 75, then 87, but beyond third dose, the concentration is almost achieved the steady state, and this becomes your AUC 0 to tau sh. Then there is another important term called as AUC, 0 to infinity. So this is area under concentration versus time curve extrapolated to infinity. Now, if you look at this particular time versus plasma concentration curve, now this is the concentration, this is the time up to which the plasma drug concentration is measured, right? So this is like 0 to t for our understanding. But beyond this t, you can extrapolate the curve and predict the possible concentration until the complete elimination of the drug substance, which is called as the AUC, which is called as the T to infinity. So beyond T, infinity. So this entire concentration until this point will become now 0 to infinity, right? This total concentration covering this also, this area also is called as the 0 to infinity. So it measures the overall concentration of a drug in the bloodstream over time from the moment it is administered, means time is equal to 0, until it is completely eliminated from the body. And there is no such time by which the complete concentration can be eliminated. So we will extrapolate based on to the some models or some hypothesis, and then we would call it as the infinity. So until this point, if I can draw once again, this can called as a 0 to t concentration, and this entire curve until this infinity is called as the 0 to infinity. So this is the if I draw with a different color for better understanding, this represents 0 to t, this green area under the curve, and this entire blue curve represents 0 to infinity. So this is the calculation formula for calculating AUC 0 to infinity. So I hope you got better clarity about different AUC terms. And in case if you like the videos, please do subscribe to the channel and do hit the like button. Thank you so much.